All right, so we are going to do trig functions in the coordinate plane. Um, this one, everybody seemed to think made sense in class, but um, I feel like it's a place that people could get caught up a little bit. So make sure you're comfortable with this, pause the video a lot, and practice anything we assign on this topic. So, first of all, I want to say that there's going to be this huge section of writing. I'm not going to pause so you can write it, but you can physically pause the video and write it, so you'll be just fine. Um, okay, so we're obviously talking about the coordinate plane, so we should draw one of those little guys. Obviously, the x-axis and the y-axis. We know that in quadrant 1, both x and y are positive, so I'm just going to label this in here. In quadrant 2, x is negative and y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive, y is negative. So that's stuff that you already know, but I just kind of wanted to throw that out there. And basically what we're doing is we're drawing triangles in here based on different pieces of information and finding the ratios. So if you think about having an angle in here, or a line, or whatever, it just keeps going, with a point on it, x, y. Then when you draw your reference triangle, and obviously this can be in any quadrant, you're going to have your reference angle, theta hat, and the distance from here to here is the x distance. So we're going to label that x. So if x was 4, this would be 4 spaces. If y was 10, this would be 10 spaces. So the vertical space is the y. And then on these we call the hypotenuse r. And that's because later this is going to turn into a circle and it's radius. All right, so if we were going to solve anything, you can see we have a right triangle. We're going to use the Pythagorean theorem, but usually in the form x squared plus y squared equals r squared. All right, so let's think about the trig functions. We have sine, and we're going to do this on the reference angle, cosine, tangent, cosecant, remember, is sine's reciprocal, secant is cosine's reciprocal, and cotangent is tangent's reciprocal. And let's use this triangle and theta hat to write these ratios. Now, of course, you can memorize these with the letters. I think that you guys are all pretty comfortable with those relationships, but we're going to use the letters to refer to later. So sine is opposite and hypotenuse, which means it's reciprocal cosecant. Oops, why am I putting? Yeah, that's right. Okay. Cosine would be adjacent hypotenuse, which means its reciprocal buddy secant is its reciprocal. And tangent, opposite over adjacent, cotangent would be adjacent over opposite. So these are the little formulas. But again, we've been doing a lot of right triangle trig, so you should be pretty comfortable with those relationships. One last thing we need to talk about, and I'm just going to kind of throw it out there and we'll get to it, is that there is an acronym to remember which functions are positive in which quadrants. In the first quadrant, all the trig functions are positive, no matter what, which makes sense because x and y are positive. In quadrant 2, sine and its reciprocal cosecant are always positive. So you might want to write that. Sine and cosecant are always positive. Tangent and its little buddy cotangent are always positive in quadrant 3, and in quadrant 4, cosine and its reciprocal secant are always positive there. So a lot of people remember the word cast to remember which is which, and that's going to help us later as we place things into the right quadrants. All right, so again, pause the video and write that if you haven't had time. And then I'm immediately going to show the next part where you should pause after I discuss. This is a lot of writing, yes, but if you write it down, it will help you. So I just wanted to talk about when the terminal side is on an axis. Remember, these are quadrantal angles. That's the vocabulary word. Um, and theirs are kind of special because it feels confusing when you just kind of look at them. But this part will make sense. First of all, if the terminal side is on an axis, we're going to use r as 1 every single time. And if it ends on the positive y-axis, so at 90 degrees, or any multiple of 90, not multiple, but add 360, any coterminal angle to that, x is going to be 0 and y is 1, which makes 100% sense because if x is 0, we're along the y-axis, so we're going to use 1 for y. And that pattern continues. Negative y-axis, x is 0, y is negative 1. Positive x, x is 1, y is 0. And negative x, x is negative 1, y is 0. Wait a second to write that down. This part we're going to go through examples for. So write all of this down, pause it, write it down, and then unpause it, and we'll immediately go to the examples. All right, are you paused? All right, so I'm going to show you an example, 4 different examples of 4 different ways that you might see these types of problems and how you would do them. So basically for these 4 problems, we're going to find all 6 trig functions. And sorry, I just thought it wasn't recording for a second. All 6 trig functions exact values. So if you're given a point, and these instructions, like I said, were on the other side, you're going to plot that point. So negative 3, 2. So we have a point right there. We're going to use that point to draw our reference triangle because this is the terminal side of the angle. And reference triangles get drawn to the x-axis. And now here's the cool part. We already know what y is. We know that y is going to be 2 because they told us that. But it also makes sense because it's 2 spaces high. We know that x is going to be negative 3. And I do want to point out that in this case, that negative 3 doesn't mean it's a negative distance. It's a directional distance. So it's 3 spaces in a negative direction. And this is going to be our reference angle, theta hat. What we want to know are all 6 trig functions based on just this information. So, set up, we're going to use the Pythagorean theorem to find the missing side, which will be the hypotenuse. We've already drawn it. That was step 1. So we're going to do 2 squared plus negative 3 squared equals r squared and solve. All right, so we now know that the hypotenuse of this is the square root of 13. And we can find all 6 trig functions now. Sine of theta hat, cosine, tangent, cosecant, secant, and cotangent. Now, we want these to be in simplified radical form. So make sure you're doing that as you go. Sine is opposite in hypotenuse, so 2 over root 13. Hopefully you have seen over time the pattern, so this is going to change to 2 root 13 over 13. If you have questions about that, please let me know. Cosine, negative 3 over the square root of 13. So that's going to turn into negative 3 root 13 over 13. And again, now we have these negatives included because they are directional. It tells where it's located in the coordinate plane. Tangent is opposite over adjacent, and that's good, already in good form. And now the reciprocal functions. So cosecant is hypotenuse over opposite, and that's already all set. Secant is hypotenuse over adjacent, and that one's all set. And cotangent is adjacent over opposite. So that is how you do it when you're given a point. Obviously, you can pause it if you need more time. If you are given an angle, still step 1 is the same. Use that angle to draw your reference triangle. So 540 degrees, or negative 540, that's 360. 450, 540 is on the axis. It's on the negative x-axis, so x is going to be -1, y is going to be 0, and r in all of these cases with quadrantal angles will be 1. So we already have all those, and we can go ahead and write the 6 trig functions. If you have questions, ask me. All right, so sine is, this is where those little y over x things come in, and I hate them because I hate to memorize them, but I guess we should. Sine is y over r, so 0. Cosine is x over r, -1. Tangent is y over x, which is 0. Cosecant would be 1 over 0, which is undefined. Secant is 1 over -1, and cotangent would be -1 over 0, which is also undefined. So those are the 6 trig functions when you're given a quadrantal angle. All right, so we did given a point up here, given an angle. Now we're going to give an equation. Of course, the y-intercept has to be 0 for these to work. So first we need to solve this equation for y to find the slope. So let's do that. All right, so now we have y equals -2/3 x. So let's graph what this would look like. The y-intercept is 0, and it says x is greater than or equal to 0. So we're going to be over here. And that's going to be determined in a second. I'll show you. So the slope from the y-intercept of 0, 0 is -2 over 3. Or we could also have gone up 2, backwards 3. And you can see that we have here a line. And this is where this part comes in, because we only want to look at the part where x is greater than 0. So we're only looking at this part of the line because x is greater than 0. Now we can figure out these numbers. The x value is 3, and the y value will be -2 because we went down 2. Remember, it's directional, not distancy. And from there, you do everything the same as before. So we're going to use the Pythagorean theorem to find the hypotenuse. Which is kind of funny because it's the same hypotenuse that we had on the other problem. And then the 6 trig functions. All right, so sine, hold on, I want to put in our little reference angle here. So sine is going to be -2 over √13. And like I said on the last one, hopefully you remember those manipulations. If you can remember the shortcuts, you'll be better off. But if you don't, you just have to do it the long way. Sorry. I have Life 360 and my family comes home and leaves home, and that's what all those noises are. Love when the radical's on the top. All right, so with a point, with an angle, with this line, and then this last one is just a little bit more confusing, but that's where the cast thing comes in. So let's think about what we know about the stuff we're given. We know it's sine, which is opposite, and hypotenuse. And we know that tangent is going to be less than 0. So if we think about that cast situation, tangent less than 0 would be in one of these two quadrants, because remember, the t and the a are where it's greater than 0, where it's positive. So we're not going to look in those two quadrants at all. Next, we're going to do sine and cosine, or we're going to use the sine ratio to draw our triangle. Sine is going to be the hypotenuse, which is 17, and the opposite side, which is going to be the y. And I just explained that really badly because somebody walked by my room and I got distracted. All right, so this is the opposite from the reference angle. So that's going to be the height, the y, remember? Y over r. So we want positive y because that's 8. So we're going to be out this way. The hypotenuse is 17. The y distance, or sine, is 8. And we don't know this distance, but there is our triangle. This is the quadrant we want. If it was down here, it would be negative because cosine is positive here. Sine, sine. Okay? At that point, you can use the Pythagorean theorem to finish the problem. And you can see the only difference in all of these problems is the initial setup. After that, everything else is the same as before. Let's see, 17 squared is 289. And this one is super awesome. X is 15, which makes setting up these ratios way better. And of course, you can always pause the video for this part. I'm just going to kind of go through it. Sine is going to be 8 over 17, which we knew. Cosine is going to be 15, but over here, negative 15, because it's in the negative x direction. So negative 15 over 17. Tangent, 8 over negative 15. And then the reciprocals, 17 over 8, 17 over negative 15, and negative 15 over 8. And there you have it. We did not find the angle measures on these. We were just working with the side relationships. That is a lot. I hope that you get the idea. If you don't, come prepared with questions, please, and we'll help you.